Okay, let's try. So, let's take a look at the first problem, which is I think I did number 2 kind of with you guys. Right, so we kind of already went over number 2. We'll go over number 3. So it's x. I'll do this one. So f of x equals x to the third. So again, I'm just going to rewrite this. Only I want f of, I'm going to put giant parentheses everywhere I see x. And inside there, instead of regular x, I'm going to put negative x. Right? Because we want the x to be the opposite. This is totally garbage. We want the x to be the opposite inside. And then we're going to go and simplify this. So negative x to the third power. We're going to simplify the negative. What's negative to the third power? A negative times a negative is a positive. Times a negative, another negative is negative. Are you guys kind of all right with that? So if you have an odd number of negatives, it ends up being negative. If you have an even number, it ends up being positive. So this is going to be negative. And then x to the third. So kind of think of it like this. Negative to the third and x to the third. Right? So the negative to the third power is negative. The x to the third power is just x to the third. And we need to call it something different because this isn't f of x, it's f of negative x. So we're going to call this g of x. Good? And then here's our drawing for it. The original one went like this. Oh, I feel like I did this one already. Did I not? No, I don't. So I went through 1, 1, and then kind of went up here. So I would pick these spots here and kind of find the ones that are on grid marks. Right? So this is on a grid mark. At 0, it's still 0. If I at 1, when x is 1, the height is 1. So I'm just going to move that across the y-axis. If it's 1 this way, it becomes 1 that way. And then same thing down here. If it's 1 to the left, I'm going to make it 1 to the right. And the upper one, this one is at 8. It's 2 to the right. I'm going to make that 2 to the left. And down here at negative 8, it's 2 to the left. I'll make it 2 to the right. So then I kind of go like this. Good. And then you can just fill in. Remember I told you guys can kind of cheat and just fill in that table off of there. X, Y. And just pick the points. So I'll pick negative 1 is 1, 0 is 0, 1 is negative 1, and then 2 is negative 8. Good? Number 4 was f of x equals 1 over x. So if I rewrite this, f, and then every time I see x, I just put a giant parentheses. 1 over giant parentheses. And again, I'm substituting in for x. What am I substituting in for x?
G.
Negative x.
Oh, yeah, like this.
It's going to put negative x in for x. And then I'm going to simplify. So is there anything acting on these parentheses either in front or up here? No, so I can take the parentheses away. So this is really 1 over negative x. But remember, the negative can either go on the bottom, in front, or on top, any one of those. And typically leave it on top or in front, but I think maybe we'll do it in front. I feel like you guys like it in front the best. So it becomes a new function, g of x instead of f of x, because it's f of negative x, is negative 1 over x. And then we have our graph. And it looks like this. Oh, I feel like I totally did this in class. I did, yeah. So if we end up, putting that one ends up going like this, and like that. I did the printing class as well.
I got a question here.
Sure.
So on this one, since it's a unit, is there two separate ones? Do we have two separate cells?
Oh,
You know what I'm saying?
there are, I mean, this one
So,
goes over here,
yeah,
this one goes over here.
so we're listing it twice with the.
Oh,
chart.
with the table?
Yeah,
No, you
Two
can just
tables.
list, you can just list a few points if you want, that's okay.
okay, because I was listing like the 3 points on top. on
That's
one
great.
table and on the other.
That's awesome,
Is that
yeah, that's fabulous.
Correct? Yeah, okay.
I won't make you guys do that, but I'm glad that you did that,
Oh.
yeah. All right, terrific. And then, number 5, I think this is one we did not go over. Or did we did go over this one, we went over this one too, didn't we?
I don't think so.
All right, so I'll just go over this. F of x equals x squared plus 1. And I'm just going to rewrite this, and again, every time I see an x, I'm just going to put a giant parentheses. And why is the parentheses important? Because when I put in negative x, this is a lot different than this. In here, what is the exponent acting on? Just the x. So everyone see what I'm talking about? Whereas here, the exponent of the 2 is acting on the whole thing in parentheses. So these two things are different. This 2 is just acting on the x. This 2 is acting on the whole thing. So that's the difference between these two, and it's a pretty big difference. So you do not want this to be wrong, right? You want it like that. So then let's simplify this. Negative x squared means you take what's inside, you multiply by itself 2 times. So negative x times negative x is positive, yep, positive x squared.
Okay, that, no parentheses?
Nope, because now you multiplied it out. Plus 1. Yep. And then I need to change this to g of x. Okay, we'll take a look at our, and it is just like this. Well, not quite just like that. It's kind of a bad drawing, but that's okay. So this one reflected itself. This one over here reflects to the other side, and this one over here reflects to the other side. It's a mirror image of itself over the y-axis. Like this side matches up with that side. So its graph is itself. Right? Its graph is just itself. So if we do our points, the points are just be the same exact points. Right? So this is 0. When x is 0, my height is 1. When x is 1, remember first you go to the elevator. So if I go left, right, first I walk to the elevator. So I go over to 1. And I go up or down. I'm going to go up to 2. So 1 has a height of 2. 2 has a height of 5. And then negative 1 would have a height of 2 as well. Good. Yeah.
Is there an order? These are supposed to be, are they supposed to be listed in,
No.
order like that, or does it have to be?
Yeah, do whatever you want.
Oh,
I'm
okay.
just asking you to pick 3 points or 4 points. That's all.
Well, but they don't have to be in ascending order like the
I'm not
descending
asking
order
for
or
that,
anything.
yeah, I know.
Okay.
If someone said, if your homework says in ascending order, then you'd have to put them smallest to largest.
Okay.
Yeah, but I'm not doing that, and I have no idea why that isn't working.
But nobody has a ladder.
I think it's just like this room, because this happened all my first semester too.
Really?
We had to consistently follow.
Oh, it comes in.
Yeah.
Yeah.
Eventually we just gave up and started using
Okay, I don't want to do that, because then we can't see kind of what's going on. All right, so let's go to move on to the next part. In exercise 5, what happens when you reflected the function in the y-axis? What happened?
It's the same.
Yeah, it's itself, right? Why is that? Right, because it's symmetrical, like you said, Fox said, it's symmetric with respect to the y-axis, to the image of itself on the y-axis. All right, so let's next page. Reflection in the x-axis. Okay. Callie, go ahead and read for me.
What was that?
Go ahead and just read from the top.
Oh, okay. Recall that to reflect a graph in the x-axis, you change the signs of the y-coordinates of all the points on the graph. Positive y-coordinates become negative y-coordinates, become positive. The x-coordinates remain unchanged. Continue.
Yeah.
Thus, if the point AB is plotted, its reflection in the x-axis is the point A negative B. When working with functions, the output of the function, or the y value, is represented by f of x. As a result, to change the sign of the y-coordinate means to change the sign of f of x. This produces the following rule for obtaining the symbolic expression that represents reflections in the x-axis.
Perfect, thank you. Right, so remember, f of x, is f of x my y or my x?
Why?
Y. F of x is my y. X is my x. Oh, this is really, really bad. Now I can't even erase the board. That one works. That one not so much. All right, I'm going to do this. Well, actually, you won't be able to see. You guys won't be able to see the book. Okay, I'm just going to keep trying. So, what happens with the y-axis? If I reflect across the x-axis. If I reflect across the x-axis, what's up here pops down here. Right? So it becomes this one goes down and becomes this guy down here. Right? So here, my x stays the same, but my y becomes negative y. Yeah, everybody on board with that part?
You could try some hand sanitizer.
Yeah, I think it's just going to make it worse for the future. Right? It'll be good temporarily. What I really need is water. But,
I'll put some water.
okay, maybe I'll do that. Yeah, throw a little bit on there. Okay, let's try this. Okay, there we have it. Thank you. I'll just avoid the red pen. Okay. So let's start over with this one and take a look at this. So f of x, this is my y. But remember, y's become negative y's. So, for example, they give us an example. F of x equals x plus 1. Yeah? Everybody on board with this part?
Mm-hmm.
But for the new function, f of x becomes, my y becomes negative y. So I really want is negative f of x. Right? But you can't have you usually wouldn't leave it at negative f of x. I would solve for this. So if I were to solve for this, what would and then we put it this way. So the new function, g of x, Let me actually, get that. Okay. So if I were to solve for this, this would be what? What would I have to do? I'd have to multiply both sides by, or multiply or divide by -1.
Divide.
Either one. You can do either one. So if you're comfortable with multiplying both sides by -1, you can do it that way. I think a lot of people like to divide by -1. I think they feel better with doing that. So we can do that. So then I get my function.
Why are you doing that, and how are you doing that?
Okay, yeah, let me switch it. I'll do it, this will be simpler. Okay, so this is really y equals x plus 1. Everybody good with that part?
Mm-hmm.
Now here's the deal. When I reflect across the x-axis, my y becomes negative y.
But you always want to solve for positive ones.
Yeah, exactly.
And negative ones.
So what I want, the reflection, so this is my first function, here's my reflection. It's a new function, y equals x plus 1, negative y, because my y becomes negative y. So if I make my y's, all my y's negative, that's the reflection. But like Fox said, I want to solve for y. So how would I solve for y? How do I make this y instead of negative y? Divide by -1. Or you can multiply both sides by -1, either one. So I'm going to divide both sides by -1. Here I'll get y. What's x divided by -1? Negative x. What's 1 divided by -1? Anybody? -1. All right, would you guys prefer I do it if I multiply both sides by -1? Would that be easier? Let's try that. I'm feeling like you guys are not sure, so let's try it the other way. Okay, so does everyone understand how I got to this point? Why I'm putting in negative y instead of regular y? Because I'm reflecting it. Right, so I'm going to replace y with negative y. That's the reflection. All right, so let's look at what if I do this. I'm going to multiply -1 on both sides. So -1 multiplied by the whole side. All right, so -1 multiplied by this whole side. -1 multiplied by this whole side. So -1 times -y is y. And then here I have to distribute. -1 times x is -x. -1 times +1 is -1.
Seems easier to do it.
Either one.
Yeah.
You get the same answer, so I don't care which way you do it. But remember, this is a different function. It's a reflection, so it's not the same as this one, so I need to call it something else. So instead we'll call it g of x equals -x minus 1. How you guys doing with this, okay? And if you look down below, right, the table down below, you'll see here are the points from the first one, right? And then if we reflect across the x-axis, you can see where they hop down to here. So -1, 0 becomes the y becomes -y. So that still stays at -1, 0. 0, 1 becomes 0, -1. And 1, 2 becomes 1, -2, because the y become the opposite. Right? Okay. All right, so you guys now have some to do. The next page, 1, 2, 3, 4, 5. Work on those ones. And again, you're making your y into -y. So I would suggest, just to keep it simpler, do this step, make f of x, just make it y equals first, where f of x is y, and then do that, replace the y with -y and solve. I think that'll just make things easier and less confusing. So go ahead and work on that. Also, your homework, this one is due, right? The inequalities homework, it's due today, so go ahead and grab that out and then pass it inward. And I'll collect those. Well, you multiply by the whole piece, and then you distribute.
Yeah.
Does that make sense? So the deal is, what I'm saying is, what she was talking about, for example, is number 3. Let's see the brown, here it is. So if I'm multiplying, I have negative y, of y equals, the negative y equals x to the 3rd power. Right? Everybody on board with this part? Now, if I multiply both sides by negative 1, what's the 3 acting on? Just the x, right? So if I multiply negative 1 times negative y, I get y equals, and then I have negative x to the 3rd. This 3 is not acting on negative x. This 3 is acting just on the x. Is everyone with me on that part? So this is not the same as, well, okay. So this and this 3 is acting just on the x. This 3 is acting on the whole negative x. Okay, now what someone pointed out is once you simplify this, it ends up being this. But that's a coincidence, right? I mean, it happens to be that. But either way, I'm sorry?
If you were, if it was the square root of an even number, then that would make it.
Right, yeah, so that's an excellent point. So if it was, for example, if it was squared, then these things would be different, for example, right? Because this would be negative x squared, and this would be the quantity negative x squared. So this would be positive x squared. That's not your problem. This is a separate problem. You know, she was just saying, here's an example of when that would make a difference.
Okay.
Thanks for bringing that up.